So welcome back to our online lecture series on textile effluent treatment. In the previous videos we saw about the secondary effluent treatment methods, and in this unit, which is unit 4, we'll be seeing about the tertiary treatment methods, and most probably we'll be seeing about evaporation alone in this lecture video. Okay, so tertiary treatment is the final or the last cleaning process that improves the wastewater quality before it is reused, recycled or discharged to the environment. The treatment removes remaining ionic compounds, or that is inorganic compounds, and the substances such as nitrogen and phosphorus. It also removes most of the cellular compounds, which is cell mass of bacteria, virus, parasites, which are harmful to the public health. This is also removed in this stage. So, as the wastewater reaches the tertiary treatment, it still has residual suspended matter and fine particles. So, the effluent treatment, right from the primary treatment, it then goes to secondary treatment, which is biological treatment, and in the later stage it comes to the tertiary treatment, right? So in this stage it contains some amount of residual suspended matter and some fine particulate matters. So further it has relatively high level of nutrients such as nitrogen, phosphorus, and it also has some microbes and odor present in it. Okay. So during tertiary treatment process, different methods are used to remove these contaminants and properties from wastewater. So the first stage of tertiary treatment is filtration. So this helps to remove the residual suspended matter which is present in the wastewater. The sand filtration is usually adopted for this purpose. In some cases, this residual toxins may be still present in wastewater, and to filter them out we use activated carbon which absorbs the toxins, and they remove them from the wastewater. So after this filtration, still some fine particulate matter may still remain in the wastewater. So to treat them further, it is then transferred to lagoons. So for wastewater treatment, lagoons, and some filter feeders such as Daphne plants are then allowed to act on them in the lagoons. In the lagoons aerobic and biologically enriched environment, for the removal of the fine particulate matter takes place there. The wastewater may still have high nutrient concentration. So in the final steps of the tertiary treatment, before releasing the effluent into the environment, so a removing of the undesirable microbes through disinfection is done, and odor removal is also carried out. So at the end we will get a clear, less cloudy wastewater is obtained in this stage. So several disinfectant agents can be used depending on the wastewater condition. So among them usually use chlorine, or we can use ozonization, or we can adopt ultraviolet light, which are used most commonly in disinfecting the wastewater. So tertiary treatment can be classified, or tertiary treatment includes the following methods. One is evaporation, the other one is advanced oxidation process, third one membrane technology, fourth one ion exchange process, and the fifth one is activated carbon treatment. This membrane technology includes furthermore 4 methods. One is microfiltration, and the other one ultrafiltration, then we have nanofiltration and reverse osmosis. So all these methods are a part of this tertiary treatment method. We can adopt any one, or we could use them in combination of one or two to treat our wastewater. So here in this video we'll see about evaporation, both solar evaporation and steam evaporation. So water evaporation, this method was first used by Phoenicians and then by Romans and followed by Chinese. They used this evaporation technique to obtain salt from seawater. So large flats are filled with seawater and natural evaporation is done using the energy from the sun. So the sun's energy evaporated the wastewater and left behind the dry salt is a conventional method of preparation of common salt. So then boiling water vapors have not changed much in the last 350 years. So some industrial wastewater evaporators are being used using this boiling water technology, and they still experience the corrosion problems. The corrosion of boilers are still a problem even in this advanced stages. Forced evaporation, so which is nothing but heating the wastewater with a heat source and causing it to boil and vaporize, which is forced evaporation is done. Then vapor is entered to the atmosphere or recaptured through a condenser and chiller. So the volume reduction here is up to 95%, and only residual salts are left behind, and this sludge can be disposed of. This evaporation rates range from 3 gallons per hour to over 100 gallons per hour, depending on the size of evaporator which we adopt and the type of heat source which we use, and also based on the humidity levels of the environment which is surrounding this heating boilers. So this boiler water evaporation efficiency is based on some basic laws of physics, and it takes about 8092 British thermal units to evaporate 1 gallon of water. So natural gas has a heating volume of 1000 BTUs per cubic foot, and 1 therm is 100,000 BTUs. So an approximate cost for natural gas is $0.50 per therm, and based on this it should cost about 0.04 of fuel to evaporate 1 gallon of water under ideal conditions. So now we can see some wastewater evaporation methods. So the first and foremost and the most conventional method is natural evaporation ponds, which uses solar energy directly for evaporation. The next one is forced air evaporator. Third one is boiler blow off evaporator. Then we have steam tube with water exhaust evaporator. We have heat exchanger boiling water evaporators. Then steam tube boiling water evaporators are there, and the most advanced one is thermo oxidizer. We'll see one by one. The first one is natural evaporation ponds. So this relies directly on the solar heat and wind naturally evaporates the water here. So the water is fed into a pond, and the sun's rays act on the pond water, and this evaporates the water. Okay, so this method requires a great deal of area. So since it's conventional, it is low and it is subject to weather changes. So the concerns are it is very slow, takes a lot of space, it requires large landmass and pond liner, and it experiences odor issues. So the next one is forced air evaporators. So as I mentioned earlier, forced air evaporators utilizes blowers. It uses some blowers. So some hot air is blown or some hot material is blown, and it forces air in a counter current to spray the water pump to the top of the column. So here we pump the water through the top and the hot air is passed through the bottom, and as a result the free falling water gets evaporated. So the evaporation rate is largely dependent on the water temperature and dew point. So this is cost effective method, and it is highly efficient also when the waste stream to be evaporated is preheated by another process, and the wastewater should not have any volatile organic compounds. So otherwise it would create air pollution. So this is the case for all the evaporators. It should be free from volatile organic compounds or it may result in air pollution. So it is not recommended for water with high dissolved or suspended solids as they deposit it in the internal area of the boilers and it blocks the waterway. So this design has no method for removing the dried solid. One dried solid settles inside, it cannot be removed in this method. So the cost estimate depends on the temperature of the waste stream. The concerns of this forced air evaporation is source of water should be preheated. So that's a drawback here, and the process generates waste. Efficiency is dependent on the relative humidity and water temperature. And here air permitting is required. So we need to supply a hot air. Then VOC should not be present, otherwise it will create air pollution. Next, boiling water tank evaporators. So here it involves heating the water to its boiling point, which is about 212 degree Fahrenheit, and exhausting the steam via an exhaust pipe. So here no way is there for removing the dried solids other than baking the tank contents down to cake. So this settled solids insulates the heat and hold into the steel, and it causes AD tank failure. Okay, so there here also no facilities for removal of the cakes formed. So this also may result in air boiler failure or tank failure. Here efficiency is between 67 to 75%. So with the addition of a condenser, you can distill the water and we can reuse it. The concerns here the same. VOC is a problem, and acid and salt will attack. That's a problem here, and cost of energy to heat the entire tank wastewater to up to 212 degree Fahrenheit is a challenge. Then cost of extra energy needed for overheating, because salt sedimentation is present, needs extra heating. That is there, and the dissolved and suspended solid should be periodically drained off in slurry solution. And since this is formed in slurry solution, then removal of this wastewater is a problem. Then risk of system running drain, meltdown of the evaporator is a problem here. Next is boiler blow off evaporator. So this can evaporate very large volumes of wastewaters at a low cost and are effective in pre-treated waste streams. So there is no method for collecting or removing suspended solids in boiler or blow off evaporators also. Here most of the dissolved solids are vaporized in the steam at 212 degree Fahrenheit and blown off into the atmosphere. So those are left into the atmosphere and it is not condensed back. So if VOC is vaporized, the same problem happens here, and all the VOC solids must be removed before bringing out to evaporation. So here the efficiency is 70 to 85%. The same way, the concerns here are no methods for collecting solids and droplet carryover, and VOC will be a problem causing air pollution here, and it is not suitable for distillation or water reuse. Next is steam tube with water exhaust evaporator. So in this reactor we have a steam tube which passes into a tank containing the wastewater. Okay. So this is basically the same concept as a boiling water evaporator, but here the hot exhaust gases are bubbled through the wastewater to improve the heat transfer efficiency. So the VOC will be vaporized and the air pollution will result. Dissolved and suspended solids are removed periodically by draining a slurry. Here also the efficiency will be 75 to 85%. And VOC is a problem here, the same acid salt problem is here, and cost of extra energy for high salt content is there. Then dissolved solid, suspended solid should be periodically enough. The same slurry solution problem will also be here. And then entire tank water we need to raise to 212 degree Fahrenheit, which is also a energy consuming process. Then here also there is a risk of the evaporator running dry and resulting in meltdown. So that's a problem. Next is heat exchanger evaporator. So here we don't directly heat the wastewater, but we introduce a heating coil filled with high temperature oil, and we pass this high temperature oil into the coil, and as a result of conduction the water gets heated and it gets boiled. So here advantage is that the tank can be made of non-corrosive polypropylene with no direct flame contact. So So the vapor can be distilled here and efficiency is between 70 to 80%. The concerns here are the same. VOC problem will be there, and there may be coil failure due to corrosion, and acid and salt attack may be still there. There may be extra content, energy required for high salt content if present in wastewater. And the same dissolved solids and suspended solids need to be drained off periodically. So that wastewater disposal will be a problem. Then the cost for heating the entire tank is also extra care should be given to that. Next is steam tube evaporators. Here steam tube evaporators uses a hot tube as a heat source. So the flame is directed inside the tube, and as a result it heats the wastewater. So here the problem is that the tube might fail. So however, this may be easily replaceable considering the other methods where replacing the tank is required. Here efficiency is 70 to 80%. The water is heated to 212 degree Fahrenheit. The vapor can be distilled and reused. Concerns are same as the previous case. Okay, so here low tube life expectancy is here because we follow a flame inside the pipe. Okay. Next is liquid thermal oxidation or thermo-oxidation. So it is an advanced process. It uses ceramic chamber to flash evaporate the atomized wastewater in a dry chamber. So atomized wastewater is heated in a chamber of having hot gases to about 800 to 1400 degree Fahrenheit. So it results in complete flash evaporation of the water. It leaves behind all the contaminant as dry ash. So very high temperature, so all the contaminants will be settled as dry ash, and all the volatiles will be burned down and actually add to the BTU value. That is, it adds to extra energy to the oxidizer. The heat source can be oil, gas, diesel, or any used oil. Here a secondary chamber thermally oxidizes the flue gases and it eliminates the air pollution problem also. Here consideration, there are no much consideration because it is highly advantageous and it takes care of all the other problems caused by the previous evaporators. And definitions, this all you know. Evaporation is nothing but conversion of the liquid to vapor. Distillation is the process of converting a vapor into a liquid by heating a vapor, converting into vapor, heating a liquid, converting into vapor, and then re-condensing it to water. So that is distillation. So then you know about volatile organic compounds, TDS, thermal oxidation, TSS, and condenser. This is all you know. So in this we saw about evaporation techniques. There are so many evaporation techniques, and we may adopt suitable evaporation techniques in order to prevent less pollution. Considering economy and all, you should choose the best evaporators for treating the tertiary treatment of wastewater. And it is an easy and simple process also when comparing with other tertiary treatment processes. Okay, so this video ends here, and thank you all.